Lesson 2.6 Special Functions. So let's go to this worksheet. Evaluate each piece of function given the values of the independent variable. So they give us this piecewise function. They want us to find f of -3, f of 0, f of 4. So the key here is right here. All you gotta figure out is which equation we plugged into. So like look at the first one. F of -3. Is that less than 0 or more than 0? F of -3. -3 is less than 0. So we're gonna type it into, sub it into this function. So 6 times -3 minus 1, -18 minus 1, -19. And then we go to B, f of 0. Well, that's actually, is it less than 0 or greater than or equal to 0? Well, it is equal to 0, so we use this equation. So I just get 3 because that's 0. F of 4, same idea. Is it less than 0 or greater than or equal to 0? It's greater than or equal to 0, so sub it into that equation. And there we go. Go on to the next one. F of -3, same idea, so it should go up here, because -3 is less than -1, so I'll type it in there. I get 9 minus 9 is 0 over -1, so I just get 0. F of 1, 1 is greater than -1, so in this case, you notice there's nothing to plug it into, so you just get 6. Right, there's no value, there's no x to plug into, so it's just anything bigger than -1 is 6. So f of 5 would be, if I did like f of 5, that would also be 6. Because it's bigger than -1, it's just 6. Next one, they don't give you a graph, but they give you a piecewise function. They don't give you an equation, they give you just a graph. So similar idea though. So if I want f of 2, remember the thing you're plugging in, the input, is the x value, it's domain. So go to 2 on your x, right there. And where does it hit the graph? Now, in this case, I probably shouldn't start with the 2, because it goes up and down, right? Open circle means no value, so it actually just goes down here. So my answer will be this guy. It looks like -5. Right, so you're at 2, follow where the graph hits. In this case, it's a little tricky because it looks like it goes up and down, but open circle does not count, so down, -5. How about f of 0? Well, 0 my x is right here. Where does it hit the graph at? Go down here, hits it at -1. F of -4, so -4 is right here. Where does it hit the graph at? Up here. At 5. 7. I can do math. So there we go. So if you just have a graph, you just gotta follow it. If I asked you what f of 6 was, you just go, okay, where's 6 on my x? Right here. And you just follow the graph, and it'll be at -2. So now we got graph piecewise functions. Oops, sorry. So I'm gonna do it like this. Let's graph 2x plus 1. So we should know how to graph these now, I believe. So I go my y-intercept of 1, and my slope is 2, so 2 over 1. So we're gonna go up 2 over 1. So I like to do it dotted first. So that's what that graph looks like. Now, I only want where x is greater than 1 at though. So here's my x. Where's 1 at? 1's right here. Follow the graph. And it's greater than or equal to, so close circle. So what's greater than 1? Well, greater than 1 is the right hand side. So anything on the right hand side, so above here. This is my full graph. That's my answer. This is not part of the graph. Right, I want this whole graph, 2x plus 1, but I only want the part that's greater than 1. So where's 1 at? Right here? Greater than. So all that. If I want, I can just erase this part. And that's my piecewise function. So let's try the same thing with this one. So we're going to graph x plus 5. So you start at 5 is my y-intercept. Right there. My slope right here is 1. So 1 over 1. So up 1 over 1. Like that. Right, so that's a graph of x plus 5. I only want where x is less than -2. Here's my x. Go to -2. Right, so I'm only looking at where x is less than -2. So right here. Notice it's no equal to sign. So it's going to be open circle. And -2. And I'm actually too high. -2. It was fine, actually. Well, whatever. So it's -2. That's where I'm at. And I only want less than. So less than means to the left. So this side. And that's my piecewise function, this part right there. All this I don't need. I can erase all that. And that. There we go. So that's how piecewise function works, right? A one-sided piecewise function. So now let's do it with multiple things. So the one right here. I think I'm going to use in different colors so it's a little easier to see. So let's do this top one right there. 2x plus 3. So I'm just going to graph it like normal. So plus 3, slope of 2, up 2 over 1. So I guess into that effect. I only want this where it's less than 0. So here's 0. Go to the graph. Open circle. Might have to erase. So I want open circle. Right? And then I only want less than. So to the left. Like that. Again, if I want to erase that, I'm going to leave that for now. And then we get the other graph. 3 minus x, or negative x plus 3. Same thing. Right, my y-intercept is 3. So 1, 2, 3, same spot. And then my slope is -1. So down 1 over 1. Right? Fall, and then to the right. This one's a closed circle. And then I want greater. Well, I should just draw the line first. Okay. Now I want a closed circle at 0. So here's 0 right there. So closed circle. So as a closed and open circle, what happens? The closed wins. It's just a closed circle now. So closed circle, and then we want greater than, so to the right. So like that. And there's my piecewise function. So my answer here would be, let's say, this. That's hard to see. I'll do it in blue. So it'll be all this. Probably want a little bigger also. So it'll be all this, all the way to here. Like all that whole graph put together. That's the answer, right? This guy, this guy, this guy. To make it a little easier, so let me erase all the stuff I don't need anymore. Probably write it in black. Right, so the answer is this graph. Like that. That's my piecewise graph there. Okay, next one. X plus 3, where x is less than 0. 3 when it's between 0 and 2, and 2x minus 1 when it's greater than 2. So I'm going to do like the same thing we did before. Let's just use 3 colors. So I'm going to use this one first. X plus 3, so my y-intercept is 3. And my slope is x, so 1 over 1. So it's kind of like that. Now at 0, so remember x is here, it's my y. So when x is less than or equal to 0, so here's my 0, x is less than or equal to here, so closed circle, nice. I want less than, right, to the left, less than to the left. So I want all this part of it. That's my graph, I don't need the top part. So that's just a graph of x plus 3. Now let's do the graph of 3. So 3, so this is like probably best to see y equals 3. That's just a horizontal line at where y equals 3 at. 1, 2, 3. So right here. This is a horizontal line at y equals 3. But I only want that between 0 and 2. Open circle at 0, but that's already a closed circle, so just nothing happens. Closed circle wins. All the way to 2. So 1, 2 to here. So this will be a closed circle also. Then you just connect them. Right, so that's my graph. Starts here, goes there, connects to there. I don't need any of this stuff. Only want between 0 and 2 at 3. Let me erase the rest of this. Okay, and then for the last one, I want 2x minus 1. So down 1, y-intercept. And my slope is 2, so up 2 over 1. Something like that. Now I want open circle at x is greater than 2. So 1, 2. So right here, it's already a closed circle, so I'll keep the closed circle. And I want greater than, so to the right. Then we can erase off the stuff we don't need. So you can something like that. Right. So in this one, again, it connects. It doesn't have to. I think we'll get one down here that doesn't connect. But in this one, the first two we did connect all perfectly. Notice it is a function, right? These are piecewise functions. didn't say it somewhere. So it should pass a vertical line test. The most common mistake I see is people do something like this. They'll draw the first one like that, and then the second one they'll go, okay, it's this part. They'll erase this part. I'm like, no, that's not a function. It doesn't pass a vertical line test. There should only be one graph on each partition. So right, there's a graph here, graph here, graph here, graph here, and a graph there. There's no two graphs on one thing because it wouldn't pass a vertical line test. So just watch out for that. Let's do the next one here. So first part, we're going to graph 2x minus 1. Then we just graph that one. So 2x minus 1, slope of 2, up 2 over 1. So like this. This time I want where x is greater than or equal to, so close circle at -2. So here's my x. -2 is right here. Hit your graph, so down there. Close circle. Now remember, I only want the less than, so that means the left side. Right, you can tell. Less than, left. I'm going to erase the rest of it because I think it's going to get a little cluttered here. Just like that. Okay, 4. So we want y equals 4. So that's all it is, right? There's nothing, so it's y equals 4. So at 4, 1, 2, 3, 4, there's a horizontal line. You just follow the tally marks. So that's y equals 4. I want that between -2, open circle, and 3, close circle. So -2 is right here, open circle, and 3, close circle. 1, 2, 3, close circle. And I only want them in between. I want between those two, so this part right there. And again, we don't need the rest. See, this time you see it's not connected. It's still a function though. Pass the vertical line test, just not connected. And then the last one, -x plus 2. So y-intercept of 2 right here. Slope of -1, -1 over 1. So down 1 over 1. And then here I only want where x is greater than 3. So 1, 2, 3, greater than to the right, and it's an open circle. I can erase the rest of it. Like that. So that's my piecewise function. Notice it does not have to be connected. It's still a function, so pass the vertical line test even right here. Remember, open circles don't count, so it's all good. Now they want me to evaluate f of -4. So there's two ways to do it. You can look at the graph. Where's -4 at? 1, 2, 3, 4. Goes to the graph. It looks like -7, 8, around there. Or you can use your table, right? -4 is less than -2. So put that equation. 2 times -4 minus 1, -8 minus 1 is -9. So that's -9 over here. F of 3, same idea, right? You can either use the graph, 1, 2, 3. Looks like it's going to be 4. Or use the table. So it's equal to 3, so use this table. So it's just 4. That. Okay, last question. They want us to make a piecewise function. So we got to make our own. So the basics of it is like sort of like this. F of x equals, right? We have an equation here, Then here's the key part. What's our x is greater than or less than? So we have an x here and an x there. Look at this thing. We have an x is less than -1. Right? This is negative. This is my x. This is -1. And it's only less than because it's an open circle. Then over here, we have an x is greater than or equal to 1. Right? It's only graphs on that portion. So this one put greater than or equal to 1. So we have the partition. Like we have two different graphs. We have this graph right here. X is less than -1. And we have this graph right here. X is greater than 1. Now all you gotta do is write the equation. Well, this is like the last lesson. Right? How do you write an equation of a line? Find 2 points that cross nicely. This would be at 1, 2. This would be at 3, 3. Right? So I guess I'm doing this one first. Find the equation of that. How do we do it? Well, y minus y1 equals m times x minus x1. I have a point. I need my slope. So I have a graph, I can do slope by hand. Over 2 at 1. So my slope is 1/2. Like that. So if I simplify this, y minus 2 equals, oh, this kind of sucks. Add 2. So y equals 1/2 x. 1/2 plus 2 is like 3/2. Right? Negative 1/2 plus 2. So 1.5, 3/2. Again, that was the right hand side, so that's this guy. Right? All I did there was find the equation of this line right here that I already had, and I plugged it into right there. I gotta do the same thing for this guy. I'm gonna make something a little easier for us. Let's do this, right? When it's a graph, we much prefer this equation. Because all I gotta do is find the slope and then my y-intercept. The reason I do it on this one is because I didn't have a y-intercept. So let's extend this graph. Y-intercept looks like 0. Right, and it wouldn't have worked on this one because I would have got something in the middle. I'm like, that's not good. Over here on this one, my y-intercept is 0. That makes it a little easier. All I gotta do now is find the slope. So find 2 points. This guy and like this guy. Find the slope. Over 2 up 2. My slope is 1. So my equation here is just y equals 1x, or just x. And there we go. That's our graph. So we went backwards. Here's the graph. We found the equation. And that's this lesson.